Okay, so this is a another graphing review problem, and this is going to be cosecant. So we're not going to really graph the cosecant. First, we'll graph the reciprocal function. And that's going to be the sine. I'll graph this, and I'll use this to get the cosecant, to get my asymptotes and all that good stuff. Okay, so I have to have just an x here, so sine, and I'll take out 1/2, divide by 1/2, and that's going to leave me with an x here, plus pi over 2. Now let's just double check this. 1/2 times x is 1/2 x, and then 1/2 times pi over 4, so it checks out. So double check that by using the distributive property. Okay, I divided out a 2 out of the bottom. Okay, so now I can tell my amplitude is going to be 3 over 2, 1 and 1/2. My period is 2 pi over b. So it's 2 pi over 1/2, and that's the same thing as if I multiply the top and the bottom by 2, I get 4 pi. 4 pi. So multiply the top and the bottom by 2 to get rid of the complex fraction. I got 4 pi, so that's my period. I've got a horizontal shift of minus pi over 2, and a vertical shift of negative 2. All right. So that's what I graph first. Okay. Vertical shift of negative 2, so I'll draw my shift line. Well, first let's figure out our period. The period is going to be 4 pi. So I'll have to use the same idea. They all start to look the same. It's unfortunately when you do it like this, but I didn't give myself enough increments over here to do 4 pi. I kind of fouled up to do twice as many. So my error, so I have to call this 4 pi. This would be 2 pi, 3 pi, 0. This would be minus pi. Okay, I do have a shift of negative pi over 2, so pi over 2 to the left, which is half, so I'm going to go like this. So this would be negative pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, which is like 3.5 pi. So it's going to be, instead of going from here to here, it's going to be shifted over pi over 2. Okay, that's my horizontal, or sometimes called phase shift. All right, I got a vertical shift of negative 2, so I'll put my shift line down here. So this is so here's my shift line. And my amplitude is going to be 1 and 1/2. So I'm actually going to go up here, up 1 and 1/2 from here, and I'm going to go down 1 and 1/2. So that's going to be my amplitude. I hope you can see that. Sorry about that. Okay. Okay, and I guess that's it. So the sine of 0 is going to be over here. So it's going to start at negative pi over 2. So let me put negative pi over 2 and see what I get. If I put negative pi over 2, Negative pi over 2, that's going to be, for x, that's going to be negative pi over 4. That's going to be 0, sine of 0 is 0, so I got negative 2. Is that right? Yep, that's right. So I start over here at negative 2, right there, on that 0 line. So just by putting it back in the equation, you could get your start point a lot, safe. Then I'm going to go up to this point right here. I kind of gone over my coordinate. I'm going to go back down to the 0 line. And then down. And then back to the 0 line. So there's your sine curve. So if you're going to graph your sine curve, it would look like that. That's your reference curve. There's your sine. Okay, but I really just need the zeros because I need the asymptotes, because this is going to be for the I wish I had a ruler. I don't have a ruler. Oh well. A ruler. So those are my asymptotes here. Here, wherever I got zeros, those would be my asymptotes. I'm going to go get a ruler for the next one. So anyway, so those are the asymptotes. And it's going to go hug these asymptotes and just come down to that point. And there's one branch, and here's the other branch down here. It's going to hug these asymptotes here, like this. And that keeps going up, close to the asymptotes and down. So there's your three halves cosecant x over 2 plus pi over 4 minus 2. That's your cosecant function, okay? All right, that's a little more complicated. And I'll use a ruler for the last ones, that's for sure. Okay, hope that makes sense.